Hello, everyone. Welcome to my talk. So, as a seasoned computer vision engineer, I won't be talking about computer vision today. I'll be talking about something else, about coding agents. My role as an encoder is, first of all, I'm head of ML and DevOps, but I also double as DevRel, and in general, pretty much dev ask me anything, like I like to call it, as an encoder. This is the second day of this conference, and I've looked at at other talks, and it feels like most of the talks are about AI, and I hope you don't feel like that when you come to yet another talk about AI. Feels like most of the talks are just mentioning AI in any way. Now, yeah, basically, apart from that, you might have heard you might have seen headlines like this. People like Mark Zuckerberg saying that AI will soon replace developers, AI will soon replace mid-level developers, and so on. Now, why those headlines started to pop up quite recently? Well, first of all, of course, the new LLM models are coming in pretty much every week. And of course, they show much better results every time they present any new model. For example, in this case, Gemini 2.5 has been shown to, of course, beat most of the benchmarks. And here specifically, I've highlighted the coding benchmarks, 3 of them. Now the problem with those benchmarks is while on them, models do show better performance. Like you can see, for example, here on the IDER polyglot, the improvement is 10% compared to Claude 3.7, for example. However, those benchmarks usually don't really reflect the reality of software development. Right. So again, in the example of IDER polyglot, what this benchmark means is LLM just needs to essentially edit a small piece of file, just essentially create a method or a function or a class, which doesn't really reflect what we stumble upon in real life, right? In real life development, we usually not always, but we usually need to modify a lot of files potentially across multiple repositories. So those benchmarks, while it's good that models becoming better at writing code, they don't necessarily reflect the quality in real life. But that's, models getting better is only one reason for these headlines popping up. The second one is AI agents, which is the main topic of our today's presentation. So the agenda with that for today is, first of all, we will discuss what agent is, what it brings to the table, and then we will switch to actual live coding session, where we will see how to create those coding agents. And then we briefly discuss, if time permits, what this means for us, for developers, and how this will change the future of software development. So let's basically learn how to build AI which potentially will replace all of us, developers. Now, AI agent, first of all, can be defined as a software that performs tasks on behalf of the user. And you might say that, well, this sounds pretty much like any software, right? Any software performs tasks on behalf of the user. And if we are talking about coding, specifically, any coding assistant performs tasks on behalf of the user, right? It could be code generation, it could be documentation generation. Regardless, they perform tasks, right? And of course, you can generate 10,000 lines of code and then spend some time debugging it. Now, the main difference agents bring to the table is what we call agentic design patterns. So there are usually 4 of them. First of all, it is tool use. So agents can use any tools at their disposal. It could be browser, it could be some local file system, pretty much any tool that they can get their virtual hands on, they can use. And these, as we will see going forward in the coding session, this will bring much more extended capabilities to the LLMs, to the AI in general. Next, they can, of course, do planning. So they don't just generate something. They don't just generate text. They don't just generate code. they can also plan ahead on what they want to do. So, they can create a draft of the plan. They can outline an essay and so on. Then, of course, they can, on top of that, they can also reflect on the work of themselves or each other or other agents, for example. And then, based on the reflection, they can come up with new plans. They can critique the existing plans and so on. And of course, those agents can also collaborate with each other, pretty much combining all of the three patterns above. So they can together do some planning. They can together critique each other. They can reflect on each other's work and so on. And through all of these planning and reflection, they of course can also use tools for their multi-agent collaboration. And you can essentially think about agents pretty much like, for example, Roomba vacuum cleaner. Now, the software on that vacuum cleaner is pretty much an agent, right? But the software itself, it would be pretty useless if it would just point to the patches of dirt, but not clean them, right? It's pretty useless vacuum cleaner. The reason Roomba is effective and the reason Roomba is helpful for us is because it has tool use, right? It can do planning. It can plan ahead what kind of route it needs to take to clean the room. It can, of course, as pointed out here by ChatGPT, it has tool use through the brushes, through the wheels, through lidars, and so on. And yeah, for some reason, ChatGPT thinks that planning for Roomba vacuum cleaner looks like this maze, which in reality is a bit different, but yeah, it is what AI think about other AIs. Now, there is no multi-agent collaboration, of course, when we talk about Roomba, unless you count this as a multi-agent collaboration. But maybe in the future, we will get some vacuum cleaners talking with each other or with some other appliances, and we will get the sort of fully multi-agentic behavior from those house appliances. Now, why does all of this matter to us, to developers, first of all, right? Well, to answer that, let's first think about what we, as developers, spend most of our time on. And now, spoiler alert, it's not drinking coffee. Now, any ideas what developers usually spend most of their time on? Debugging. I can see a lot of debugging. I can hear a lot of debugging. Okay. Okay, it's a bit hard for me to hear, to be honest, but yeah, I heard a lot of debugging, and yeah, that's partially, I guess, correct answer. Now, there was a research done in 2015, pretty much 10 years ago, but I think it still resembles the reality, and maybe it's actually even shifted a bit in terms of understanding. Now, to debug things, we obviously need to understand what's going on, right? We need to understand the error, we need to understand the code, and so on. But of course, understanding is not just about debugging. It is in general about understanding the requirements of the project, understanding the code itself, and so on. And based on the research, understanding actually consumes around 70% of the time of the developer, and only 5% is spent actual code editing, which is, I guess, kind of daunting if you think about this really. But that's the reality. And current code assistants, like for example GitHub Copilot, they focus pretty much on those 5%, but they don't help us with the rest of 95%. Now, getting back to the agents, if we overlap this diagram with those patterns which we just discussed, we will see that, for example, tool use is obviously an important part of, obviously editing code, but also we use tools when we are outside of IDE, when we do UI interactions, maybe even for understanding we might use some tools like debugger, for example, right? Of course, the same goes for the planning. We need to understand things to do planning, right? We can't plan something without understanding the task first, the requirements first, and so on. Of course, to reflect on these plans, to reflect on the task, to reflect on the code, we also need to have understanding, first of all, but we also might need to do some navigation, we might need to do some UI interactions and so on. And of course, for multi-agent collaboration, for us talking with each other, right, with our colleagues and so on, we also need to hopefully understand what we are talking about, right? We also probably need to spend some time outside of IDE, spend some time on UI interactions, I know message in Slack and so on. So basically all of the agentic patterns, they pretty much overlap with our everyday life, everyday time spent. And that's why agents can really, well, either help us be more productive, be more efficient, or as Mark Zuckerberg said in his interview, fully replace developers. But yeah, we will talk about that part at the end of the presentation. But for now, let's first of all switch to the slide. Then let's finally do some coding. Now, all of the code which I will be showing is available on the GitHub repository over here on this QR code. The way I like to structure the coding session is we will go through pretty much several stages, and hopefully not these stages. So we will go through several stages, starting from some baseline, where we will only use the vanilla LLM, and then we will gradually build upon that to our full-blown multi-agent collaboration system, where multiple agents will work together to build something for us. Now with that, let me switch to Jupyter Notebooks here. So first of all, of course, let's establish our baseline. Let me zoom in a bit. Now as a baseline, and all of the code will be in Python. If you don't know Python, don't worry. I will explain everything, and it's pretty easy to read. So you don't need to be proficient in Python to understand what's going on. Now as a baseline, we will start with pretty much regular calls to LLM. In this case, GPT 4.1, which was released I think 1 week ago. And hopefully all of you, or at least most of you, use AI in any form, right? Be it ChatGPT, be it Claude, be it any coding assistant. And maybe you even did something similar in your experience, or maybe experienced something similar. But basically, if you try to ask ChatGPT, right, and this function is basically just sending a message to ChatGPT and giving the response back. Now, if you ask ChatGPT about anything that goes outside of its knowledge, be it some real-time interaction with a website, be it some sort of up-to-date knowledge, it will pretty much fail, right? So it won't be able to give you, for example, the response time for Google. It won't be able to access your local machine because, well, it doesn't have access to your local machine, right? So it won't be able to, give us a ping. It won't be able to tell us what Python packages I have on my computer. And of course, it won't be able to tell us what's UniPython 3.14, which is not yet released. I think it is still in the pre-release form. So let's see if it will give us something. Hopefully, the internet will continue to work. Yeah. So the model itself was trained on, the knowledge cutoff for the model was on June 2024, and I think at that stage there were some initial updates on Python 3.14. So in this case, the model does know something, but if you try the same with the older model, it won't be able to give you anything about Python 3.14. Now let's fix that. Let's fix those issues with the base model, right? So let me switch to the first basic agent. Now, what we will be doing here is basically instructing OpenAI or OpenAI ChatGPT model to follow the React framework. Now, React stands for reason plus act, which basically means that we instruct LLM to go through several stages. First, it needs to do a thought. So it basically needs to think about what kind of action it needs to perform to fulfill the user's request. Then it needs to select the action. And this will be our first output from the model. Basically, it would need to define which action it wants to run, and then we will be going to the pause phase, where the actual action will be run. After that, once the action is done, we'll go to the observation stage, where LLM will observe the actual output of the action, and then hopefully will give us an answer, or if the observation is not enough, it will go into the second loop, or into the third loop, and so on, until it collects enough information to give us the answer. So this framework can pretty easily be implemented through this system prompt. And you can find this specific prompt online. It's pretty much just 5 lines of text, which essentially describes what I just told you. So we are instructing LLM to run in a loop of thought, action, pause, and observation, and in the end it needs to give us the answer. So thought describes the thought, pretty much doing some planning. Then action defines the tool, and then observation is analysis of that action. And here we also provide a few actions available to the LLM, to the model. So in this case, it has access to ping, right? So it can ping, it can do ping. It has access to bash, so it can run any bash commands, and it also has access to web search. So basically, it can do any web search for whatever it deems necessary. And we also provide some example sessions. So basically, we are just showing the LLM showing the LLM some references. So in this case, the question would be how many islands make up Madeira. I live on Madeira, so that's just a quick sort of Easter egg here. Now, the thought from LLM potentially could be that it should do a web search for the Madeira. The action would be in this format, so it would need to define the name of the tool, and then after the semicolon, it would need to define the search term. And then there will be a pause, and then based on the observation, it should hopefully give us the correct answer. So let's click the prompt. Now for the model, we are again using GPT 4.1. It's pretty much the same model as before, as in the baseline. And here again, I'm just sending a message to the model and getting the response. Over here, I'm defining my 3 actions, which I just described. So first of all, we have ping, we have bash for executing bash commands, and we have web search, pretty simple implementation of web search, and we will see more sophisticated examples in going forward. Now let's see if those actions actually work. Hopefully they do. Yeah, so we can ping Google. In this case, it gave us, I guess, 500 milliseconds. Python, locally I have installed 3.12.6, which is correct. And then for the web search, we got this data from the page about Python 3.14, which makes sense, right? And we get ourselves a lot of data from that website. Now let's also define our React framework in the code. So basically, this function is essentially implementing what I just described in the React framework. We are going through the loop of action, thought, action, pause, observation, and answer. And here, first, of course, we send the message to the model with our user input. After that, we check if the model decided to do any action based on the action semicolon pattern. If there are any actions, we will perform that action or actions, right? And then we will send these the result of these actions to the model. And then hopefully that would be enough. But if not, we will go to the second loop and so on. We will limit the maximum of iterations to 5 just to avoid any unnecessary infinite loops. Now let's check our simple agent on the same prompts we had before. So first, let's see what is the response time for Google. And in this case, as you can see, the model decided to use the action ping, which makes sense, right? It's the typical command to check the response time. So we did run the ping for google.com. We got the observation. And then based on this observation, the model gave us the answer, which seems to be correct. Now let's see if now the model would be able to get the Python packages from my machine. So it decided that it needs to run the bash command, which again makes sense. In this case, it is a command pleased. So after running pleased, it got a long list of packages, which I have installed, and then it gave us the answer based on this observation that I have a bunch of packages apparently. All right, and then the last one with the web search, hopefully. So again, in this case, the model decided to do an action about Python 3.14. It got to the same website as we've seen before. It got a lot of data from that website. let's scroll all the way down and let's see. Yeah, over here it gave us the answer with some summary from basically from the website. So with just a simple prompt, we already can extend the capabilities of LLM beyond what it already knows. We can, for example, update its knowledge, right, to any action which happens right now. We can allow it to access our local machine. We can potentially allow it to access any remote servers and so on. Now, of course, we could, for any action we want LLM to be able to perform, we could do pretty much the same as I did here. We can define each action separately, and we have, I know, for example, if you think about Git, right, it has a lot of different actions. So it can do, I know, Git checkout, it can do Git commit, and so on. So for each action, potentially we would need to define that action here, which occupies quite a lot of time, first of all, and it also occupies quite a lot of tokens and prompts from LLM. Luckily for us, quite recently, the company Anthropic introduced a MCP protocol. MCP stands for Model Context Protocol, and here they basically introduced a way for models to use different tools defined through MCP. Now, MCP protocol contains of two main entities, MCP servers and MCP host or MCP client. MCP server is basically anything that can interact with with the environment, with the tools. It can be local resources, it can be remote APIs, and so on. But essentially, MCP server is responsible for sending those requests, executing those actions, and so on. And then MCP client or MCP host, it could be some LLM, it could be ID, it could be pretty much anything that runs the LLM. Through MCP protocol, it first of all gets a list of actions, a list of tools which are available from that server. And then through this schema, through this MCP protocol, it also can call those tools on that MCP server. And as you can see, as I said, MCP servers can potentially extend capabilities to pretty much anything. So anything you can code, you can convert to MCP server. Right? So again, it could be access to some local resources. It can be access to some remote resources, some APIs, Jira, Confluence, whatever you use in your everyday life. Right? And it is pretty easy to define MCP servers on your own. We will see that in a second. But this is how the actual tool, MCP tool, looks like. It's pretty much just a structured input and output. In this case, it is a tool for creating branch in Git. Right, and this tool requires 3 items: owner, repo, and branch, which I guess makes sense, right? And for every tool, you get pretty much the similar structured input, and then you also get the structured output schema for LLM to use when it wants to get the answer from the server. And there are quite a lot of different third-party or community-provided services which you can find, for example, on this repository, Model Context Protocol /servers, or there are also several MCP registries already available where you can find any MCPs available to use with just a single click. And as you can see here on the list, this is not exhaustive. I think that right now there are probably more than 500 different MCPs. And you can see they essentially allow LLMs to interact with tools. First of all, things like Grafana or JetBrains or ClickHouse, which you might use in your everyday life. So pretty much any IT tool, right? But it also extends beyond that to tools to feed things like Flight Radar, for example. So you can potentially connect LLM to Flight Radar and allow it to check the flights in real time. Now let's see how we can actually implement those servers, and then how we can actually use them with our LLMs. Let me switch to here to Agent with MCP. So first of all, the way we can define our servers, and they can be defined in different languages. In this case, again, it's Python, but there are SDKs available for defining your MCP servers in JavaScript, in Java, I think also in Kotlin, and in Python, of course. So as you can see, it is pretty straightforward. So in this case, we just use this sort of syntactic sugar from Anthropic fast MCP, and then we just define our function. In this case, again, it's the bash tool, bash tool to run for running bash commands, and basically we just wrap it with a decorator, which converts it to the tool. And that's pretty much it. So it's just pretty much just 2 lines of code, and we can convert through these 2 lines any code we have, any function we have, to an MCP server MCP tool. Now with that, let's actually jump into the notebook. Now in this case, I will be using Anthropic, not OpenAI. The reason being for that is Anthropic is more optimized for tool use. The model itself, the Claude 3.5 or 3.7, even though, although the recent models from Gemini or from Google, like Gemini 2.5 or OpenAI's GPT 4.1, is also pretty good with tool use. So again, over here, we are defining our MCP client, which is essentially just connecting to the servers, getting the list of tools available from the servers, and then we will do the simple query to the model, including the list of tools. So over here, we just adding the list of tools available with the name, description, and the input schema to the model, to the input of the model, and that's pretty much it, right? Not much code needs to be written, and we will actually see later how we can even remove the need to write this code as well. Let's execute that section. And then, of course, we also have the chat loop function, which basically just allows us to, chat with our model and use those MCP servers. Now, let's first use the bash tool, which we just seen defined in a couple lines of code. For that, we will need to have also the config. So in this case, it's a JSON file, which defines how we call the MCP tool. So in this case, as you've seen, it's a Python script. So we will just have a comment Python, and then as argument, we will have the actual name of the file. However, you can also run those servers in any form. It can be Docker image, it can be npx package. We will see some examples later. But in this case, it's just Python and the name of the file. So let's try to run our MCP client with Claude, with Anthropic, with just a bash tool, and let's ask it to, let's say, list all files. Hopefully, yeah. So it decided to run the command ls-la, which is, I guess, a proper command, right? And it got the list of files and also gave us some comments about those files. All right, that's good. Now let's try something else. Let's try more servers. So over here, I have also the list server full.json. So let's first examine its content. I have here defined 4 MCP servers. First one is for file system. As you can see, it is an npm package, and yeah, it's just run as npm package. I also have the web search tool through the Brave search, which is run as Docker image. I have the tool for fetching URLs, which is a Python package, and I have our bash tool, which we just seen before, which is also a Python package. Now with that config, let's try to run our agent again. All right, so we are loading all the tools. So it connected to the file system tool. It should now connect also to the search. Yeah, so basically for each server connection, we see the list of different tools available at our disposal. So for the file system, it is some, file reads, file writes, searching files. So any file system operations which you might find useful. We also have the web search, as I mentioned. We have the fetch for fetching URLs and the bash tool. So let's try something what we were already seen asked the ChatGPT before. Let's see what's new in Python 3.14, and hopefully Claude will decide to do a web search and get us the answer about Python 3.14. Yeah, so it did call the Brave web search tool with a query of Python 3.14 new features release notes. It got some like I'm assuming they got some web search results, and they give us a summary of the tools. Oh, sorry, of the updates in the Python 3.14. We can do pretty much the same with the file system. We can ask it to create a file called hello.txt with content hello world. So essentially, through file system, our LLM model can access our local file system and in this case manipulate files. Let's see, we should have, so we have the new file over here, created 9 seconds ago, and the content is indeed hello world as we requested. All right, so now we had a few MCP servers here at our disposal, which are essentially, let me scroll to the servers, which are essentially just a simple functions, right? It can be, again, the Python code, TypeScript code, whatever, right? It's just essentially just a small algorithm which allows us to call file tools or whatever. But you can imagine those tools in itself being an agent. So we could have some supervisor agent, and which would have other multiple agents at its disposal, and of course in addition to those tools which you already have. So basically you can potentially build a multi-agent hierarchical system where some agents can call other agents, and those agents can also call other agents, and so on. Now let's see how we can actually do that. Again, with a few lines of code. Let me switch to a multi-agent notebook over here. So for that, we will introduce even higher level of abstraction. We will use LangChain and LangGraph to define our graph of interaction of agents. Now you can do pretty much the same on your own. It is again more or less just a structured input and output and calls between different LLMs, between different entities. But it's always nice to have some syntactic sugar on top of that. So that's why we are using LangChain and LangGraph. We are again defining pretty much the same tools which we had before, which are bash tool, search tool, and file system tool. And we also add to the mix what I call here human tool, which basically would allow LLMs to call or to ask humans any questions. So it could be some requirements, it could be some clarifications, and so on. And then we will define our hierarchical system pretty much as a supervisor node. You can think about it as for example, product manager, which will have 3 team members: front-end developer, back-end developer, and DevOps engineer. So pretty much like a schema like this. So we will have user, us, of course. We will have supervisor node, which is kind of product manager, and we will have few agents, which are in our case, front-end developer, back-end developer, and DevOps engineer. So for the system prompt for the supervisor, it is pretty straightforward. We are just saying that it's a supervisor and it has a few team members at its disposal. Nothing fancy here. And we create our supervisor node with just a few lines of code, which is again just structured output and input as I mentioned before. And then similarly, we will define our front-end, back-end, and DevOps agents with again a simple prompt. So in the case of the front-end agent, we are just telling it that it's a front-end developer. It needs to create applications, pretty straightforward. And we can also mention that you can ask clarifications from the human client. The same goes with the backend agent, and the same goes with the DevOps agent. And as you can see here, we also creating them as React agents. So pretty much like we've seen before with our React framework, we instruct them to go through this think, act process with just single line of this function code. Now and over here we're just building a graph of those supervisor and virtual developer agents interacting with each other. Let's also try to visualize it. There were some issues with the Mermaid plots recently, so let's see if we get an ASCII graph or nice looking Mermaid plot. Based on the delay, it will probably be ASCII. That's fine. Over here, I have just a small helper function yeah, so we have our start node, we have our supervisor, which can interact with front-end developer, back-end developer, and DevOps engineer. Now, of course, you can also imagine those agents being able to interact with each other, but in this case, all of the interaction will go through the supervisor. Over here is just a helper function to color the output from LLM, as we will see in a second. So I won't be going into details of that function. And then the main sort of task for those agents would be to create a conference website. It would need to contain 3 parts: front-end on TypeScript on React, backend in Fast API, and we will use also Postgres database for storing the talks. So essentially, it would need to, well, ideally have help from front-end developer, from backend developer, from DevOps engineer, all working together. So let's see what those engines will come up with. So first, supervisor decided to call the front-end developer, which decided to first check the versions of Node, Python, Docker, and Docker Compose. So over here we have the comment from our virtual front-end developer agent. We decided again, as I said, to call terminal with the following command. And got the output, and it went on to, let me disable scrolling. It went on to creating a project. So it started with creating some directories, and then this part usually takes a long time because npm installs are usually quite a long process. So let's see. In the meantime, we already have our directory for the website, and we have the one for directory for the backend and for the front end. In the front end, we already have some Node modules. We should get some code as well over here. All right. So installs are going fine. We got some Python installs as well. All right, and then after that, it went ahead and started implementing the actual code for the website, for the conference website. In this case, for its front end, and yeah, it will take some time. We probably won't be waiting until it to finish. Yeah, but it will just go on until either stop it or until it finishes the task. Now, this was hopefully pretty nice exercise for you to see how the agents can be defined. But of course, you can play with it on your own. You can define the agents on your own, bring your own tools and so on. But of course, why spend time of that when you can start using agents already today without any hassle of implementing them yourself. So, without any effort. And with that, let me briefly introduce Zencoder, our product of the company. So what we do is we are essentially a coding assistant, which you can install on either VS Code or JetBrains. And we bring all the agents, similar functionality which you've seen before, the agentic functionality, directly to your IDE. And this in turn allows you pretty much do the same exercises you've seen before. So in this case, you zoom in. I ran this beforehand, before the conference, before the talk. But basically, I asked it to do pretty much the same. In this case, I switched from Python to Spring Boot to Java just to spice things up. But the rest is pretty much the same request. And our query agent went on ahead and started creating some directories, and then started to creating some code first, I guess, in TypeScript, JavaScript, and then also some code. Let me scroll down a bit, and then also some code in Java. So in total, it created probably around 20-30 files, and including Docker file and Docker Compose. So let's actually see if that will work, if that will run. I didn't modify anything after that input, after that output. So let's try to run the Compose and see if it will actually. Okay. See, looks like Compose down. Okay, let's try one. Okay, something is using my C. All right. Okay, yeah, I think that's another agent which we were running in the background. I think it started the Docker here as well. Let's see. yeah, as you can see, while we were talking, the other agent, which I was running in the background in the Jupyter notebook, it started to do pretty much the same. It started to run Docker over here in the background, and it actually created us a website. Let's actually check it out and see what it came up with. All right, so our multi-agent system actually created us a website. It doesn't look, very nice, of course, but that's because we also didn't provide a lot of details. We didn't provide a lot of specifications. So most of the items here, most of the content here was hallucinated by LLM. Well, not hallucinated, but was invented by LLM just based on its own thinking process. But then, of course, we can iterate on that and ask it to change the content, make it nice, look nicer, and so on. Let me actually stop that section. See Docker pause down over here. Interesting. Let's me quickly stop this and switch to our pause down. All right. Okay, let's check our Java backend. See? All right, now it's working. So let's see what Zencoder created for us. I think it's on the local host. Just on the local host, I believe. Yeah, so, this looks a bit nicer. Again, we didn't provide much details to Zencoder or to our multi-agent system, but still they were able to create a nice looking is probably the discussable term, but yeah, it was able to create a website. We also can submit talks as we requested, and we can also check the talks. Can't load the talks for some reason, but I don't think there is anything to load actually. So let's try to submit something. Test. Let's do all the tests. Test, and it's let's say it's light talk. Okay, I need to actually put an email. Okay. All right, looks like something is wrong with our backend, but okay, we can. Zencoder should be able to fix that later if we would need to do that. Well, yeah. All right, so let's go back to the slides. So you've seen sort of progressively how we can introduce agents into our everyday life, and of course, even though the presentation itself was about coding agents, of course, all the same principles can be applied to AI agents in general, and they in turn can be applied to our everyday life. But if we are talking specifically about developers, about AI coding assistants or AI coding agents, all of those developments in AI agents, of course, bring the question of what's next for the developers. And well, there are several views on that, several perspectives. Of course, some people think that, well, developers, among other professionals, will be replaced. And you can again think about it from different perspectives. You can be happy about this. You can be not so happy about this. Maybe you always wanted to chase your every long life dream of being a goose farmer after 20 years at Microsoft. And then, once AI replaces you, hopefully you would be able to chase that. But of course, at least for now, with the models we have nowadays, AI can't be trained without the data. So of course, there would be an option for you to create a data for AI to train on, which is not going away, at least for now. So and that's one option. But then, of course, even though AI can create a code, it can create a full-blown websites, as you've seen before. Still, the part about understanding doesn't go away. So even if we are talking about vibe coding, which is quite popular term nowadays, right? When you just try to reroll every time the LLM creates something, still you need to understand what's going on, right? To do the vibe debugging, if you will, right? So in our sort of company philosophy and in my personal view, I think at least for the next few years, the way developers software development will change is basically it would be us collaborating with the AI agents, not being replaced. So essentially, you would be able to offload some of the repetitive or mundane tasks to AI agents, to AI in general, and then you in turn would be able to focus more on high-level tasks. So essentially, you would be able more of a manager of virtual developers rather than coder. It's a coder yourself. And again, it could be a good thing, it could be a bad thing, depending on how you look at it. But I think this change would be rather imminent, and with the development of AI, we all will become more of managers. Now, if you want to see how you can actually use Encoder to be able to manage virtual agents, come to my talk tomorrow in the SD hall about developing production-ready apps with AI agents. And with that, few QR codes for you to use. So on the left, the QR code is for our website where you can sign up to try Encoder. On the right is my connection details. So if you want to, if you have some questions, if you want to talk after the presentation, feel free to reach out to me on LinkedIn. And one other small announcement. You see here this QR code, not QR code, hashtag over here, built with Encoder. We decided to sort of run a small hackathon for all of the people who came to the talk. If you would be interested, if you want to win a 1-year enterprise subscription for Encoder, we are running this small hackathon where you would need to build something with Encoder, create a video of what you built, and then post it on social media with this hashtag, and then we will select the winner who will get 1 year of enterprise plan for free. We have 24 hours for that hackathon, so yeah, I guess by the end of the conference we will have hopefully the winner. And with that, happy to answer any questions, and thank you for your attention.